Assalamu alaikum. Today we will discuss the properties of divisibility. First of all, we have two examples. 1 divides 2 and 3 divides minus 15. If 1 divides 2, then what happens? 1 into 2 is equal to 2 and the remainder is equal to 0. And if 3 divides minus 15, then 3 into minus 5 is equal to minus 15. After subtraction, the remainder is 0. In early classes, we have solved many examples in which divisibility is involved. But now, today, we will prove some properties of divisibility. First of all, reflexive property. In the previous lecture, we defined divisibility. We recall A divides B, two integers A and B, then A divides B if there exists an integer k such that B is equal to A into K. This is the basic definition of divisibility. We use this definition in several properties of divisibility. First of all, reflexive property. What is reflexive property in number theory? N divides n. N is any integer, non-zero integer. N divides n. It means every number divides itself. Now prove. Prove that n divides n. We can write n is equal to n into 1. N is equal to n into 1. Obviously, they are equal. By definition of divisibility, we have an integer 1 belongs to Z. So, there exists by definition of divisibility integer 1. Therefore, we have that n divides n. This is the first property of divisibility, reflexive property. I repeat, n divides n. We can write here n is equal to n into 1. By definition of divisibility, we have integer k which is equal to 1. So, by definition of divisibility, n divides n. The second property is that 1 divides every integer. One divides every integer. Mathematically, the statement of this theorem is given by n is any integer. Proof. We can write n is equal to 1 into n. Obviously, this is true. This implies that there exists an integer k which is equal to n. So, by definition of divisibility, we have that 1 divides n. This is the second property of number theory of divisibility, that 1 divides every integer. N can be written as 1 into n. Then there exists an integer k which is equal to n. So, by definition of divisibility, 1 divides n. Next, the third property is that every integer divides 0. every integer divides 0. Mathematically, every integer n divides 0. N is any integer. Proof. We can write 0 is equal to n into 0. N into 0 is equal to 0. So we have an integer k, this is equal to 0. There exists an integer k and the value of k is equal to 0, you know. So by definition of divisibility, we have that we conclude that n divides 0 where n is any integer, hence prove that every integer divides 0. For example, we have 0 and 3 outside. 3 divides 0. How? 3 into 0? 0. The remainder is 0. This is the counter example of this property. Now the fourth property is that 0 divides only 0. If 0 divides n, then the numerator must be equal to 0. Proof. Since we have that 0 divides n, then by definition of divisibility, there exists an integer n. Such that n is equal to 0 into n, and 0 into n is equal to 0. So n is equal to 0. Hence proved. If we have 2 by 0, then the answer of this quotient is infinity. But if we have 0 in the numerator, means 0 by 0, then this is quite different from this.